Dear students, the course name is Process Control, and myself Dr.N.JAYA, Professor in E&I department. Today in lecture 1 we are going to discuss about the introduction to process control. That is, you, dear students, you have already completed your control system course in your previous semester. So before entering into the process control course, we must know the difference between your control system and the process control. So just I am going to give some small brief introduction to process control. That is, what is mean by plant or a system or a process, what is mean by control, and what is mean by process control, what are all the hardware elements presented in a typical process control loop, and while designing a process control loop, what are all the basic requirements needed. These are all the things we are going to discuss in lecture 1. So first we must know what is mean by a system. A system is a collection of components connected in a particular fashion to perform a specific function. Number of components are connected in a sequence to perform a specific function is called as a system. For example, you can say that the power system. The power system can be called as a system. I will tell you why a power system is called as a system. Because in power system, the number of components, what are all the number of components present in a power system? There may be a generator, there may be a load, there may be a buses, there may be a transmission lines. So there are number of components, they are all connected in a sequence and it is performing a specific function. What is the function it is performing? We are trying to generate the power, right? So the system can be, the power system can be called as a system. Similarly, the control system. Why a control system can be called as a system? Again, the number of components are connected. If you take a temperature control system, the number of components, for example, the tank, the process tank, the heater, the pipelines, the valve, they are all connected in a manner to control the temperature of the given process. So a temperature system can be called as a system. Then the educational system. What is mean by educational system? For example, you can take our university, the staffs, the students, the classroom, the blackboard, the chalk piece, everything is connected in a manner to perform a specific function, right? What is the function it is doing? The teacher or the lecturer is delivering the lecture, the students are gaining the knowledge, they are writing exams, they got promoted, they are getting degree, so they are performing a specific function. So this can be called as a system. And similarly, the banking system, the bank staffs, the customers, the money, everything is designed in a manner and it is performing a specific function. So these things can be called as a system. Coming to the plant, the system in process control, we are not going to call it as a system. Instead of system, we are going to call it as a plant or process, right? So first we must know what is mean by a plant. Plant is nothing but the arrangement of processing unit. If you take any chemical plant, there are number of components are involved. For example, distillation column, there may be a distillation column, there may be a reactor, pump, valves, pipelines, etc. They are all connected with one another and it is performing a specific function. What is the function it is performing? The plant's overall objective is to convert certain raw materials into a useful product. That is, this is a plant which receives the raw material and converts it into a finished product. So the plant's overall objective is to convert the raw material into a finished product in the most economical way using available sources of energy. So that is the overall objective of any plant. So during its operation, the chemical plant must satisfy several requirements. I will tell you the requirements one by one. What are all the first requirement? What is the first requirement is the safety requirement, right? What is mean by the safety requirement? The safety operation of a chemical plant is the primary requirement of the well-being of the people working in the plant. That is, I will tell you what is mean by safety requirement. Suppose if we design a reactor that should be operated below 100 psi. Let us assume it should be operated below 100 psi. In that case, we need a pressure control system in order to ensure that the reactor is operated below 100 psi, right. So this is called safety requirement. Not only pressure, they may they may impose some constraints on the temperature, maybe on the chemical composition, etc. So these are all called safety requirements. Then the next requirement is called production specification. The production specification, what is mean by production specification is a plant should produce the desired amount and quality of the finished product. I already told you the overall objective of the plant is to convert certain raw materials into useful product, right. So when it converts into useful product, there are some specifications which are specified on the productivity. For example, we may desire a plant should produce some 2 lakh pounds of ethylene per day with 99.9% of purity. In that case, we need a control system to ensure that the plant is producing 2 lakh pounds per day of ethylene with 99.9% of purity. So these are all called as your production specification. Then coming to the next requirement, which is called as the environmental regulations. I will tell you what is meant by the environmental regulation. The various federal and state laws may specify the limits of various parameters. That is, whenever the plant is operated, there may be some conditions on the parameters of the plant. For example, the temperature should not exceed this much amount. For example, the amount of sulfur dioxide that a plant may eject to the atmosphere should be within this limit. And similarly, the quality of water that can be returned to a lake or pond should be within this limit, right. So these are all called as the environmental specific regulations, right. The government will propose some laws, right. So you should not, you have to design a plant in such a way that you should not overcome these specifications. Then coming to the next specification, which is called as the operational constraint. The various type of equipments used in a chemical plant have constraints inherent to their operation. These constraints should be satisfied throughout the operation of the chemical plant. That is, for example, a pump should have at least some positive suction head. That is, the tank should always never be over flooded, and similarly it should not go dry, right. Similarly, for example, if you take distillation column, the distillation column should not be over flooded, and similarly the temperature of the reactor should be maintained within the limit. Otherwise, what will happen to the catalyst? It will destroy the catalyst. So these are all called as the operational constraints. Then coming to the last requirement, which is called as the economics. I will tell you what is meant by economics. The operation of the plant must conform with the market condition, that is the availability of raw materials and the demand of the final product. We are going to convert the raw material into useful product, but you have to satisfy some economic specifications. What is meant by economic specification? You have to utilize the raw materials in a effective way. That is, what is the meaning of effective way? Minimum cost, maximum profit. We have to ensure minimum cost and maximum profit. So these are all the requirements of any chemical plant, right. So these specifications require the continuous monitoring of the chemical plant. Then coming to the hardware elements of a typical process control loop. I have taken a simple example, which is a heat exchanger, to explain you about the hardware elements present in the process control loop. This is a heat exchanger example. The process I have taken is a heat exchanger. There is a hot process which is going inside, and there is a cold process, steam, which is coming out, right. This is your process variable. I will tell you what is mean by process variable, and another one is the manipulated variable. I will tell you the actuating signal or the manipulated variable. I will tell you the definition what is mean by the manipulated variable. Then what are all the other components, important components present in this diagram is the first one is the sensor, then the temperature transmitter, then the controller, the actuators, that is your converters, I to P converters, then the control valve, right. So if you take this process, the objective of the plant is to keep the temperature of the process steam to the desired value. The temperature of the process steam to the desired value. So, the variable we are interested in control is the temperature of the process steam, right. So, I will tell you what is, so the measurement system includes the temperature sensor, I already told you, the transmitter, controller, converters to actuate the control valve, process, recorders, computers and necessary software, right. I told you already about the two type of variables involved in the process control. One is the process variable, that is the variable we are interested in control. If you take this process, the variable we are trying to control is the temperature of the hard process steam. So, that is your process variable as far as this example is concerned. Coming to the manipulated variables which can be adjusted by a human mechanism. In case of human control system, manual control system, the variables can be adjusted by a human operator. In case of automatic control system, these variables are adjusted by a controller or control mechanism. Then coming to the first important element, which is called as your sensor, right. So, sensors are used to measure the physical or chemical variables and are the main sources of information about what is going on in the process. As far as this example is concerned, the sensor can be your RTD or it may be a thermistor or it may be a thermocouple, because we are trying to control the temperature of the hard process steam. Okay, then the next element is, the important element is the temperature transmitter. I will tell you tell you some information regarding this temperature transmitter. First, you must know what is mean by temperature transmitter. Transmitter is a device which converts any type of input signal into a standard form which is suitable for transmission. The standard form is normally 4 to 20 milliampere current signal or 3 to 15 psi pneumatic signal which is suitable for transmission. I will tell you the reason why we are selecting 4 to 20 milliampere. You may raise a question, why we are selecting 4 to 20 milliampere? Why don't we select 0 to 20 milliampere instead of 4 to 20 milliampere? I will tell you the reason. The 4 milliampere is called as the live zero and 0 milliampere is called as a dead zero. I will tell you why we are not selecting 0 to 20 milliampere instead of 4 to 20 milliampere. You just come back to this diagram. If you see the diagram, I think you can able to see this red line, right? You can able to see this red line which separate these instruments into two parts, right? The lower part of the instruments are called as the control room instruments. The upper part of the instruments are called as the field instruments, right? There will be a set of wires which will carry a signal from the temperature transmitter to the controller. Again, the controller is in the control room. Again, another set of wire will carry a signal from the controller to the I to P converter. We all know that the I to P converter is in the field instrument, the field side, right. So, another set of wire will carry a signal from the controller to the I to P converter. Suppose, let us assume that if there is any break in the process line, what will happen? The meter will read only 0 milliampere. In that case, we cannot distinguish whether this 0 milliampere is due to the break in the process line or maybe due to the actual 0, right. That is what we are not using 0 milliampere. Instead of that, we are using only 4 milliampere. In the same way, you can raise a question, why don't we use 12 milliampere or why can't we restrict with the 16 milliampere? The reason is, if you decrease the amount to 12 milliampere or 14 milliampere, what will happen is the resolution is very small, right. And similarly, if you increase beyond 20 milliampere, what will happen is the power dissipation will be more. So, the 4 to 20 milliampere is chosen conveniently, which will give a voltage drop of 1 to 5 volt when we drop across a 250 ohm resistor. So, this is the reason for selecting 4 to 20 milliampere. I hope now it is clear why we are using 4 to 20 milliampere instead of 0 to 20 milliampere. Then Why we are transmitting current signal? Why not the voltage signals? We all know that the voltage signals are very much affected by electromagnetic interference, whereas the current signals are not affected by electromagnetic interference. And one more thing, up to a particular value of wire resistance, the current signal doesn't change, whereas the voltage signal will change. And similarly, if we transmit a voltage signal, what will happen is, suppose if there is a overloading occurs, what will happen is it will damage the equipment and it may cause fire accidents also. That's what we are always preferring current signal instead of voltage signals. Okay, then the next important component so I already told you about the sensor, the transmitter. The next important component is called as the controller, one of the important heart of the process control loop, one of the important component which is the heart of the process control loop. Again, there are two types of controllers are available. Depending upon the control action, then they can be classified as direct acting controller, inverse acting controller. I will tell you what is mean by direct acting controller and what is mean by inverse acting controller. The direct acting controller. What is the meaning of direct acting controller is, when the process variable increases, the controller output also increases. That is, when the process variable increases, the controller output also increases. Or in the other way, when the process variable decreases, the controller output also decreases. So you can call it as increase action or decrease action. What is mean by inverse acting controller is, when the process variable increases, the controller output decreases. Or in the other way, when the process variable decreases, the controller output increases, which is called as increase action or decrease action. You just see the graph. This one is the upper diagram is called as your inverse acting controller. The other name for inverse acting controller is positive gain controller, because its gain is always greater than 0. I will tell you why. Suppose the graph, you just please note it down. The definitions are based on the process variable and controller output, whereas the graph has drawn between the error and the controller output. When the error is, let us assume that when the error is minus 2 degree C, what is the value of controller output? 4 milliampere. When the error is minus 2 degree C, the controller output is 4 milliampere. When the error is plus 2 degree C, when the error is plus 2 degree C, the controller output is 20 milliampere, because you see the graph, it is maximum, right, maximum. So what happens to the error? Error increases from minus 2 degree C to plus 2 degree. What it implies? Process variable decreases. So when process variable decreases, the controller output, what happens to the controller output? Controller output increases from 4 to 20 milliampere. So decrease action, I already told you, decrease action is called as inverse acting controller, right? So this one is called as the inverse acting controller or positive gain controller. Then coming to the next one, which is the direct acting controller. At minus 2 degree C, the controller output is 20 milliampere. At minus 2 degree C, the controller output is 20 milliampere. At plus 2 degree C, the controller output is only 4 milliampere. So what happens to the error? Error increases, or in other words, the process variable decreases. When the process variable decreases, what happens to the controller output? Controller output also decreases. So decrease action, or in the other way, increase action, which is called as the direct acting controller. I hope now you are clear with the direct acting and inverse acting controllers, right? Then coming to the next important component, which is called as your control valve, right? The control valve, the very popular example of any final control element is the control valve, right? Control valve is essentially a variable resistance to the flow of fluid, in which the resistance and therefore the flow can be changed by a signal from the process controller, because the controller output will normally operate your control valve through your electro-pneumatic converter or I2P converter. Again, there are two types of valves are available. One is called direct acting and another one is called reverse acting or inverse acting, right? Or you can say that the first one may be called as your air to close valve and the second one may be called as your air to open valve. I will tell you what is mean by air to open and air to close valve. In the air to close valve, when the air supply is increased from 3 to 15 psi, when the air supply is increased from 3 to 15 psi, the valve gets closed. Air to close, that is more air, more close. Similarly, coming to the air to open valve, if you supply more air, valve will get open, right? More air, more open. Air to close, air to open. In the air to close valve, actually you are going to apply the pressure on the top side of the diaphragm in such a way that the diaphragm will tend to move in the downward direction, so that when you supply more air, the valve gets closed. Whereas in the air to open valve, the diaphragm is designed in such a way that you are going to design the you are going to apply the air pressure on the downside of the diaphragm. So, it will try to open your stem in the upward direction. So, more air, more open, that is what this is called as your air to open valve. Now, let us assume let us take a small example, a flow control loop, right. In the flow control loop, there is a transmitter, you are going to measure the process steam, right. There is a process steam, you are going to measure the process steam with the help of the transmitter. The transmitter output is 4 to 20 milliampere. The output of the transmitter is given to a controller, and there is a valve which is a, let us assume that the valve is a air to close valve, air to close valve. Now, can you tell me whether the flow controller should be a direct acting one or inverse acting one? You just think of it, whether the controller should be a direct acting one or inverse acting one. I will tell you, most of the transmitters are designed in such a way that they are all direct acting. Now, the valve is air to close valve. What is the meaning of air to close valve? More air, more open, right? More air, more open. That is, when we increase the supply pressure from 3 to 15 psi, the valve gets closed, right? So, what can be this flow controller? You just think of it. I will tell you the answer in the forthcoming lecture. Thank you.